Hi everyone, this is Mr. Youngren once again, and we are getting close to the finish line in Algebra 2 with 3 lessons left to cover. In this lesson, we're going to find inverses of exponentials and logs, and this is going to be page 200 in your notebooks. And just like always, we're going to have you start by working through the opener. So with the opener, I'm going to ask that you find the inverse of f of x, which is 3x plus 2 cubed minus 8. Now, just because it's been a little while, let's remember how we find inverses. And what we do for that is, I'm first, instead of f of x, going to use y, because it really doesn't matter. And then the first part in finding inverses is to change the domain and range, right? That's what we do with inverses. So to denote that, we switch x and y. And so then we have x equals 3, y plus 2 cubed minus 8. And so your task now is to solve for y. So I'm going to let you go ahead and hit pause and do that on your own. And then go ahead and hit unpause when you're ready to check your work with mine. All right, well, here's what you should have done. So when I'm trying to find trying to get y by itself, the first thing that we want to do is actually add 8, because we're trying to get the y plus 2 cubed isolated so we can undo that cubing. So I add 8, and then after that, I'm still trying to get the y plus 2 cubed by itself. This 3 wants to multiply, so I can divide both sides by 3. And then to undo cubing something, I'm going to take the cube root. So after I take the cube root of both sides, that leaves us with y plus 2 on the right side and the cube root of x plus 8 divided by 3 on the left side. And so the only thing left for us to do is subtract 2, which gives us our final inverse. So now that we have the inverse, remember our notation for writing inverse is that it's f to the power of -1 of x. That just shows whoever's looking at this work that f of -1 is the inverse of f of x. So we just undid everything. And I just copied down the function. Now our domain here, when you think about cubic functions and what x values work, really everything works. We can take the cube root of negatives, we can take the cube root of 0, and of course we can take cube root of positives. That's different than square roots, right? Square roots, we can't take square roots of negatives, but we can take it of 0. So in this case, our domain is -infinity to positive infinity. Now we're going to do this exact same thing with exponentials and logs, where we're going to solve for the inverse by switching x and y. So let's go ahead and jump right into it. So before we start working on finding the inverse, I like to start with the domain and range, because if I find the domain and range of my original, I can just take my original domain, it's the range of my inverse, and the original range becomes the domain of the inverse. So with exponentials, this is 2 to the power of x minus 3 plus 5. The domain is -infinity to positive infinity, because we're allowed to take any number can be an exponent, right? We can have negative exponents, we can have 0 as an exponent, and we can have positives as an exponent. Now the range is limited, because if you think of what the graph of an exponential looks like, we have that horizontal asymptote, and our graph never goes below the horizontal asymptote. The horizontal asymptote is that value that comes after the exponential term, which is 5. So 5 is as low as our graph will go. It'll get infinitely close to 5, but it won't actually get there, or it won't actually touch it. And then it's going to go all the way up to infinity. Now, again, I like starting with this because now the domain of my inverse is the original range, so 5 to infinity. The domain of the original becomes the range of my inverse, so negative to positive infinity. And so now we don't even need to worry about that at the end. I'll still talk about it at the end, but let's go ahead and start finding the inverse. So the first thing, just like last time, is I'm going to rewrite this equation with y. And then after doing so, I'm going to switch x and y. So it's 2 to the power of y minus 3 plus 5. And now I need to go ahead and get the y by itself. So when we're working on this, the first task is to isolate the exponential term, which we only need to do one thing to do that here. And that's to subtract 5. So I get x minus 5, and it equals 2 to the power of y minus 3. Now, once we get here, I'm like, what the heck? How do I get the y down? It's an exponent. How do we do that? This actually stems from the original introduction to logs and how we convert an exponential into its corresponding log statement. So let's pretend that I had x equals 2 to the power of y. So we're basically taking the same thing, but a little more simple. I can write the corresponding log for this equation really easily, right? The way that we do that is I write the word log, I take the base of the exponential of 2, that's the same base of my log, and I need to change the position of the other two things. Now, when I do this, I like to hide the word log because now this looks like an exponential, and instead of it being 2 to the power of y, I want this to be 2 to the power of x, and now it equals y. And look at that, I have isolated y. In fact, we have found the inverse of that equation already. So we actually want to do the same thing here. With the x minus 5 and y minus 3, those are terms that are grouped together. So I like to put parentheses around there because now when I do the whole switching thing, the x minus 5 is going to stick together. The y minus 3 is also going to stick together. So here's our conversion. I'm going to write the word log. I'm going to keep the base the same of 2. Then I'm going to go ahead and hide the word log, and I'll use my pens just so my arm doesn't get in the way. Here we go. And now I'm going to switch the position of the other two things. So instead of having 2 to the power of y minus 3, I'm going to have 2 to the power of x minus 5, and it equals y minus 3. But remember, this isn't an exponent, right? This isn't 2 to the power of x minus 5. It's log base 2 of x minus 5, which equals y minus 3. And so the only thing left for us to do to get y by itself is to add 3 onto this log. So log base 2 of x minus 5 plus 3 equals y. And so for our inverse, we're going to use the correct notation of f to the power of negative 1 of x and equals log base 2 of x minus 5 plus 3. And we've already found our domain and range. Now, if we had not done that, how could I find it? Well, we can't take logs of both 0 and of negative numbers. So what makes this 0 is the number 5. But 5 itself doesn't work because that would cause us to take the log of 0, which we can do. So 5 is the smallest number that we're going to get to, but it has a curved parenthesis or curved bracket because we never can use 5 exactly. We can use 5.00000, as many zeros as you want to list, and then a 1, but not 5 exactly. And then any number after that's going to work, so any positive number. So 5 to infinity is our domain, and with the range of every log is going to be negative to positive infinity. All right. That is how we take the inverse of an exponential. Now let's do the opposite and take the exponential, or take the inverse of a log. So once again, I'm going to start off by identifying my domain and range of the original, where the range, or the range of all logs, is negative to positive infinity. The domain is restricted by the fact that we can't take the log of 0 or negative numbers. So what makes this log 0 is the number 2. I can't use 2 on its own. That's why it has a curved parenthesis. And then it's going to go to positive infinity. So 2 itself makes it 0, but I can't use 2, but I can use the first number after 2, which is 2.000, as many zeros as you want to list, followed by a 1. Okay, so now the range of my inverse was the domain of the original. The domain of my inverse is the range of my original. And now we're ready to go ahead and find our inverse. So once again, I'm going to write this with y instead of f of x. And I'm going to switch x and y. And so now we can start trying to get y by itself. Now, similar to what we had to do with the exponential inverse, I need to isolate this log term. So that includes the base and anything we're taking the log of, which in this case is y minus 2. So the only thing that I need to do here is subtract 4. So I have x minus 4 equals that log of 4y minus 2. Now, once again, let's pretend that I had x equals log base 4 of y. So basically taking this exact same thing, but making it a little more simple. I can rewrite this equation as an exponential statement. So once again, how I'm going to do that is I'm going to hide the word log so that it looks like an exponential to me. So this to me looks like 4 to the power of y equals x. And when I write it as an exponential, because this still is a log, it's 4 to the power of not y. I need to switch that position. So to the power of x, which equals y. Right? And there was a log, so we wanted to write an exponential. So that's what we're going to do here, the exact same thing. So when I'm trying to go from log to exponential, I'm first going to put x minus 4 in parentheses because that's one term together. We need to group them together. And so then the exponential, the base is 4. I'm going to hide the word log just because it's easier for me to see kind of where to go from there. And instead of it being 4 to the power of y minus 2, I need it to be 4 to the power of x minus 4. And now it equals y minus 2. And I can check, did I do that conversion correctly? Are the bases the same? Absolutely. Did I switch the position of x minus 4 and y minus 2? I did, because it used to be 4 to the power of y minus 2, but now it's 4 to the power of x minus 4. And again, that was a log. Now we have our exponential. And the only thing we need to do to get the inverse is add 2. And then we're all done. So the inverse, f negative 1, don't forget the notation, equals 4 to the power of x minus 4 plus 2. With the domain being negative infinity to positive infinity. And again, right, we have that horizontal asymptote at 2, which is our range. We've already found that, but I still like to check and make sure it doesn't match up with what I would think it would be had I not found it right off the get-go. All right, well, that is it for this video. Thanks for watching. Make sure you complete your video check-in and have a great rest of your day.